Hello students, welcome back to RD Chemistry. In this video, I will explain the concept of the Gibbs free energy chain delta G naught and the equilibrium constant K equilibrium. Fine. Here I will be writing the formula directly. So we have got Gibbs free energy chain delta G naught is equal to minus NF E naught cell. N stands for number of electrons involved. F is nothing but 96,500 coulombs constant. And E naught cell. How to calculate E naught cell? E naught cell is equal to E naught of the cathode minus E naught of the anode. This is the formula in terms of SRP values, standard reduction potential. Remember, we'll be writing in terms of reduction potential. Okay. Now, how to find out the K equilibrium? For that, we have the formula E naught cell is equal to 0.0591 divided by N, then log K equilibrium. Okay. So, based on this, we'll solve some problems. Read this question. Calculate the maximum work that can be obtained from the Daniell cell. What is Daniell cell? Daniell cell is a zinc is in contact with the zinc sulfate solution, and copper sulfate is in contact with the copper. This is a Daniell cell representation. For this, number of electron transferred are equal to 2. What is the question? Question to calculate maximum work done. What is the work done? Work done W is nothing but it is a delta G naught itself. What is delta G naught? Gibbs energy chain nothing but the maximum amount of energy available to do the work. Okay. So formula minus NF E naught cell. Correct. So it is a direct straightforward question. So we'll have to calculate E naught cell first. E naught cell is equal to E naught of the cathode minus E naught of the anode. Correct. Now when you're writing the cell representation, initially we have zinc. This is the anode. After the solved, you have the cathode. Therefore, cathode is copper. Copper value is given. See carefully whether it is oxidation potential, reduction potential. Zinc 2 plus becomes zinc. So reduction reaction, reduction potential. Copper plus to become copper 0 state. It's a reduction reaction. So both are reduction potential. So we'll be writing in terms of reduction potential, cathode minus anode. Therefore, 0.34 for copper minus anode minus of 0.76. So this will be equal to 1.1 volt. Okay. Now we'll calculate W, maximum work done, that is nothing but delta G naught, which is equal to N is equal to number of electron transferred 2 into Faraday's constant 96,500 coulombs into E naught cell we have calculated 1.1. So this is equal to minus 212,300 in terms of joules, or finally minus 212.3 in terms of kilojoules. Right? This is one of the simple questions that can be asked. Fine. Read the second question. For the reaction A plus 2 B plus giving A plus 2 to B, E naught values give 1.18 volt. Calculate equilibrium constant. Direct straightforward problem. See here, 10 power 10, 10 power 20, 30 and 40 they have been given. Okay. Now, simple one directly. E naught cell is equal to 0.0591 divided by N log K. So it is a 1.18 here, 0.0591 divided by, what is the N value? Here total charge is equal to plus 2. Here total charge is plus 2. So N is equal to 2. Okay. Therefore divided by 2 log K. Therefore log K will be equal to, so see here, 10 power 10, 20, 30, 40, they have done approximation. So I'll be writing approximately. This answer will be or log k is equal to 1.18 into 2 divided by 0.0591. So this is approximately equal to 40. I'll take. Okay. Log k is equal to 40, or k is equal to anti-log of 40, and anti-log of 40 is equal to 10 power 10 it comes. Sorry, 10 power 40 it comes. Okay. So that is D here. That's why I give the option here, because we can do the approximation easily here. Fine. Here the simple problem can be asked. If you are watching for the first time, please do subscribe, share and like the videos. And please do support me. Thank you for watching. Have a nice day.